Hi, welcome to Lesson 22C, Theoretical Probability. The goal of today's lesson is to learn how to calculate probabilities using theoretical probability. So, theoretical probability is the likelihood that something is going to occur, some event will occur. It is also referred to as mathematical probability. It is the chance of that event occurring in any trial of the experiment. So, suppose we're tossing a coin, and obviously we've got heads and tails for a coin, so there's two outcomes that could occur. So if you're saying, okay, well, what's the chance is going to, or what's the probability that'll land heads? Well, that'll be 50%, right? So it's either going to be heads or tails. There are two outcomes, and heads is one of those two outcomes, so we get one of the two. So suppose we're saying, okay, well, let's toss the coin 20 times. If we know that theoretically heads will turn up one out of two times, or 50% of the time, because of the two outcomes and the one event of heads, then when we flip a coin 20 times, theoretically, we would say that heads would occur 10 times. Okay, that's that's theoretical probability. We're using the idea of, in theory, it'll land on his head one out of two times because of the two outcomes. So theoretical probability is what you expect to happen. When we talk about experimental probability, experimental comes from, well, it lends its name from experiment. So experimental probability is what actually does happen. That's the actual occurrence of what happens, and that is the result from using experiments or going through some trials with an experiment. Okay, so there's the difference. Even though ideally it would be the same, they have exactly the same outcome, chances of the outcome. So suppose we take a look at this spinner, and each of these sectors are of equal size. Then if we were to say, well, what's the probability? Well, here we've got, these are all the odd number, or some of the odd numbers here. So 1, 3, 5, 7, 9, 3. So we've got 2, 4, 6, 8 sectors here. And they're all of equal size. So theoretically, each one of these has equal chance of occurring. So suppose we wanted to find the 5. So the probability of a 5 occurring when we spin the spinner is going to be 1 over 8, because there's only one 5 and there are 8 spaces that are all of equal size. Okay, and so as 1 over 8, we can say that that's 12.5% likelihood, or we could even change that into a decimal and say 0.125. Okay, so those are the chances that a 5 will occur. Suppose we say, okay, well, what if it's a single digit value that occurs? Well, we've got 1, 2, 3, 4, 5 single digits. So the probability of a single digit occurring when we spin the spinner is going to be 5 out of the 8 total sectors. Okay? So in general, for some event to occur experimentally with an equal likelihood of possible results, we can say the probability, move this down here, the probability of some event A occurring is equal to the number of members of event A divided by the total number of possible outcomes. Okay, and we could then say that that's the same as the number of, in event A, whatever we're looking for, over the size of the universal set. Okay, remember we looked at that, or we will look at that, sorry, sooner. So when we look at a probability, I showed you a line graph before. So any probability is in the likelihood of between 0, in the range of between 0 and 1. So remember, 0, the event is impossible to occur. 1 means that the event definitely will occur, and anywhere in between are generally the probabilities that that the event occurs. Now, complementary events, now it's the complement, not complement. Complementary events are events that consist of all the outcomes that are not in the sample set. Okay, so suppose we have a crudely drawn universal set, which is all the possible outcomes, and so we have some subset of the event occurring. Then outside that subset is the complement. Okay, so this is the complement of A, which is that it is not part of this subset. Okay, so A complement, that's how you read that, A complement is equal to the outcomes of the universal set U that are not in the subset A. Okay, so if we're looking for the number of heads, for example, then A complement would be the number of tails. Or if we were looking at the rolling a die, okay, this is rolling a die, then, and we're saying, okay, well, how many odd numbers will there be? Well, if the sample set are odd numbers, then the complement, so that's A, the complement, which is A prime, would be all the even numbers. Okay. Generally, this complement isn't necessarily listed with this part here in a Venn diagram like this. The main subset is labeled, and then the complement would just be outside. So if we were to list the complement, we could say, well, A is the set of 1, 3, 5, and then A complement is the set of 2, 4, and 6. Now, if A is the event that we're looking for and A complement is the event that we're not looking for, then if we were to add up those two possibilities, the probability of A occurring plus the probability of A complement occurring, well, when we roll a die, one of these numbers is going to turn up. So the probability of A occurring plus the probability of A complement occurring is going to equal 1. Because one of these things has to happen. Whether it's part of event A or part of the complement of A, it's irrelevant, but when you add the two together, it does equal 1. If we were to rewrite this, we could just say, okay, well, the probability of the complement of A is equal to 1 minus the probability of A. This is a different way to see it. We can use grids to find probabilities. We can use two-dimensional grids, which gives a nice visual representation of the outcomes of the probabilities. So if we're to look for the favorable outcomes of some sort of event, some sort of experiment or whatever, suppose we say, okay, so here's coin B, so we're going to flip 2 coins now. So here's coin B, and coin A will be here. So the outcomes of coin B when it's flipped is they're either going to be tails or heads. And the outcome for coin A is also going to be heads or tails. So if we were just to draw lines to attach to the outcomes, then the intersection of those lines would indicate what sort of outcome has occurred. So this right here means a tail of coin B and a tail from coin A. We could say here that outcome right here is a tail of coin B and the head of coin A. Okay, so it's just a way of, and then from there we could calculate probabilities. So the probability of this occurring is of course going to be 1/4, and the probability of this occurring again will be 1/4. Being that this is a visual representation, it's a very quick way of being able to determine probabilities just by looking at the grid. Okay, so that is the extent of theoretical probability. We're going to be looking at some examples tomorrow. In the meantime, please look at examples 4 and 5 from page 576. Then take a brief look at exercises 1 through 7 on page 577. Then look at example 6 and listen to the self-tutor from page 578. And then we'll be taking a look at the exercises to practice your skills on page 578, numbers 1 to 3. So thanks for watching, and we'll see you in class.